Welcome everyone, I'm Max, software engineer from StreamNative. Today I'm going to talk about podcast migration best practices, in-place versus geo-replication approaches. Let's get started. First, a little bit of information about myself. I'm staff software engineer at StreamNative. I'm working on building the cloud-native ecosystem surrounding the Kubernetes. I'm part of the StreamNative Cloud Infra team. Our team is responsible for reliable, scalable, and secure infrastructure that can support our growth and enables us to deliver the top-notch products and services to our customers. And here is the agenda today. I'm going to go over 5 topics in this presentation. First, I will introduce the podcast migration and motivation to show you what scenarios can drive us to make a decision to migrate our podcast. Then I will go deeper to approaches the in-place and geo-replication, what underneath, how we achieve the migration goal, and then I will compare the pros and cons of these 2 approaches to help us make better choices when we decide to migration. Last but not least, I will share 3 practical use cases to show how we do migration on StreamNative Cloud and what benefits we can get. All right, first, let's see why we need podcast migration. There can be a lot of reasons for us to do so. You might need to switch your geographic regions. You might need to upgrade your online infrastructure. You might need to move from self-hosted deployments to managed services. For example, your current podcast deployed by Helm chart, you need to migrate your existing podcaster to StreamNative Cloud. But anyway, to achieve these goals, how we do that? To answer this question, first, let's review the current architecture. As you can see, this is one classic podcast consists of 3 core components. The first is zookeeper, which is responsible for storing the metadata across the whole podcast, your talents, interests, your topics, anything related to metadata stored in the zookeeper, and other components talking to zookeeper to fetch metadata. And second is bookkeeper. Bookkeeper is where your actual data stores. Your message data stored as bookkeeper ledgers, and third is broker. This is where the core business logic for producing and consuming. For such a classic podcast cluster, users typically deploy in Kubernetes environments, and the goal of podcast migration is migrate this podcast cluster from one Kubernetes to another Kubernetes, maybe in different region, different VPC, or different environments. And we need to migrate this data from one place to another place. So how to achieve that? For now, we typically have 2 approaches, in-place migration and geo-replication migration. Next, I will go deeper these 2 approaches to see what underneath, how we achieve the migration goal with these 2 approaches, and the pros and cons. Okay, first, let's see the in-place migration. In-place migration essentially is an expand then shrink approach. As you can see in this feature, as you can see in this picture, this is one unified podcast cluster consists of 2 colors. The white color represents the old podcast cluster, maybe running in one Kubernetes in different region, and the blue color represents the new podcast cluster running in another Kubernetes cluster. And our goal is to gradually replace the old one with the new one. First, for the zookeeper, by leveraging zookeeper dynamic configuration, we first do expand the zookeeper node from 3 node to 6 node. Then gradually we will replace the old node with new node. And in next slides, I will give more details about zookeeper dynamic configuration. And for bookkeeper is leveraging the auto recovery, and that's who do the real data copying job. The auto recovery will copy the ledgers from old bookkeeper node to new bookkeeper node. And this step may take a while, depends on the size of your data. Automatically replicating the ledgers essentially is like copying large amount of files over the network from one machine to another machine. And if your ledger entry is very small, it becomes copying a large amount of small files over the network, so it can take a lot of time. And thanks to the stateless broker, we don't require additional setup or configurations for broker. We just need to simply scale up and scale down. And you may have found that the zookeeper dynamic configuration is the core and basis of the whole in-place migration. And next, I will give more details how zookeeper dynamic configuration play in this migration process. As you can see here, with zookeeper dynamic configuration, this is the basis of our in-place migration. It makes the new cluster joins the old cluster as a big one unified cluster. So let's start from the top left here. The old zookeeper is a standalone here. The leader is zookeeper 3. And when we start migration, we will start a new zookeeper. And we will join the new zookeeper as observer in the old zookeeper in one unified zookeeper. But at that time, the zookeeper column still have not changed. The zookeeper column is still 3. And then we use a reconfig to add the new zookeeper node to the old column to expand the column to 6 from 3. So as a third step, our expansion work should be completed, and at that point, we can start bookkeeper, auto recovery, replicating data, etc. And after that, when we do shrink, we will use the reconfig to remove the old zookeeper from the new column and make the column size scaled down to 3 again. And once new zookeeper column update to 3, then we can start scale down the old zookeeper pod. Until that, we will get complete new zookeeper cluster will be served for the new Pulsar cluster. So as you can see here, the zookeeper cluster plays important role across the in-place migration process. And next, let me give detailed steps to show you how we achieve that. For expand phase, first we need to enable dynamic configuration on the old zookeeper. There is configuration key reconfig enabled. We just need to set it to choose and restart the old zookeeper pod. Then we launch new cluster, and the new zookeeper will join the old zookeeper to begin to become one unified zookeeper cluster. So once expansion complete, we will start shrink. First, we will need make old bookkeeper to be read only. This step is to prevent any new messages go to the old cluster. We will need to make any new messages go to the new cluster and then start bookkeeper decommission. If you have multiple bookkeeper replicas, you have to decommission one by one. And as we mentioned before, the bookkeeper decommission can take a lot of time, and it depends on the size of your ledger data. So if your ledger have 100 gigabytes or 1 terabytes, it may take more than 10 hours or even 1 day to accomplish. And so, but this step is a core step to do the real data replicating. So we have to wait this step to accomplish, no matter how long it takes. But once this step accomplished, we can stop old broker and proxies if they have. And the last step will remove the old zookeeper from the core and stop the old zookeeper as we described before. So for now, we can see you are happy to use a new Pulsar cluster in a new environment, maybe with new VPC, etc. As you can see here, it's pretty intuitive with in-place migration. Then, from a high-level perspective, it's just like scale up, then scale down. Okay, so next, let's see how the geo-replication achieves migration goal. Geo-replication actually is a built-in Pulsar feature, but we can utilize this feature to achieve our migration goal. As you can see this picture, on the left is old cluster and the right is new cluster. And our goal is migrate the topics in the old cluster to the new cluster. So once we configure the new cluster as a peer cluster for the old cluster, then there is one built-in component. The broker replicator will start replicating the topic from the old cluster to the new cluster. It will keep replicating and we don't need to do anything. It's everything automated. So as you can see here, this is only one core component and only core and basis process we need to care about. So next I will show you more details about broker replicator. As you can see here, let's assume there is one topic 1, leaving the old cluster, and there are 3 messages, message 1, 2, 3. And once we configure the geo-replication, which means the new cluster is a peer cluster of the old cluster, then the built-in broker replicator will start working. So how does it start working? Actually, it's processed inside the broker pod, and the replicator maintains 2 things: the cursor and the producer. So once new messages arrive in the topic, the producer inside the replicator will raise the topic and produce messages to the new class we configured, and it will exactly produce to the same 10 namespace topic and with the exact same message content. But I want to point out the message ID will be changed since they install in different bookkeeper cluster, so they have different ledger ID and entry ID. And another thing I want to point out is, as you can see here, there is a blue components in the new cluster. This means there is producer in the same time producing messages to the topic while a broker replicator replicating topics to this topic. So the order of this the order inside this topic will be shuffled or randomized, but the internal order of the messages from the old cluster will be reserved. And also we can replicate the subscriptions, and so our consumers can start consuming from the right positions. Okay, here I will show you the detailed steps how to configure the geolocation for migration. First, you need to add a new cluster to your old cluster with a pulsar and min command. Pulsar and min command clusters creates new cluster. Then the old clusters knows oh, there is a new cluster coming, and it will be my peer. And then we need to configure as talents and the namespace level. So so the peer cluster has permissions to replicate the messages. These two steps also achieved by the pass the main command. It's very simple and intuitive. And there is optional step. If you want to replicate your subscriptions, you just need to update your applications to use replicate subscriptions. And lastly, you just need to move your consumers and producers to the new cluster by using the new service URL. And I want to point out the real replicating starts immediately once we complete the step 3. So once the namespace configured the peer cluster, the replicator will start replicating topics from old to new. Okay, so we can see lots of differences between the inputs and the geo-replications. No, so next, let's see the differences. From high-level architectural perspective, the in-place migration actually is one cluster operation, but the geo-replication migration is 2 cluster. So for in-place migration, all the data stored in one cluster in one unified metadata store, and there is no message ID change, and all the history data replicated from old to new is completely a migration operation. But for geo-replication, it's also has migration effect, but it's more like backup, since there are 2 message content, and the message ID is different because they are spread into 2 different parser clusters. And next is a table to summarize the pros and cons and differences of in-place and geo-replication migration approach. For in-place migration is seamless to client application, since we can simplify this approach as a cluster scale up and scale down. It's very intuitive, and all data persistent in one unified cluster. But the cons of in-place migration is complexity and infra requirements. We have to set up the infra and the network connectivity. During the zookeeper dynamic configuration, we have to set up the network connectivity like VPC peering. We have to let the old zookeeper can talk with a new zookeeper. They can talk to each other. So it depends on the network requirements. So if your network unable to talk to each other, then we are unable to using the in-place migration. And there are a lot of steps we need to be manually executed. It's not fully automated. And another cons is large history. This might take a while. It's not take a while. It may take a long time if you have over 1 terabytes ledger data. As for geo-replication, the process basically the less changes required the user side, and actually we can use a global zookeeper. It doesn't require the network connectivity, and it provides backup functionality. Since you can bring up more than 1 peer cluster, you can bring up 2, 3, and more. peer clusters, and your data can be replicated to multiple regions, multiple Kubernetes clusters, and your data will never be lost. And the cons also obviously is very intuitive, that you need to set up per namespace, since the Geo-Replication is not class-wise. So for each namespace, you have to do the setup with pass-admin command. Obviously, you can use a script to do that, but it will add extra workload to the existing broker, since it's a built-in process inside the broker. So once you set up the Geo-Replication, the broker needs additional CPU memory resource to do the replicating. So it might affect your producing and consuming effective. So you have to increase more resources to your broker. And as we mentioned before, the message ID will be changed. So if your consumer have the logic depends on the message ID, so it may be affected. So so for this zero, the Geo-Replication might not suit for your consumers which have heavy dependent on the message ID. And another console Geo-Replication is existing messages will not be replicated. Since just imagine you have one old cluster running for couple of days or months, and now you want to start replicating, and you want to start migration. Once you configure the Geo-Replication, the replicate only starts replicating the messages from the point you configure the Geo-Replication. If you want to replicate in the history data, you need additional setup. From practical perspective, in StreamNative cloud, we currently use the in-place approach for customers who want to completely migrate their Pulsar cluster from one place to another place. And for Geo-Replication, customers typically just need to do simple setup, and they can have the backup functionalities. So next, I will give you several user cases. The first case is AWS. This customer set up the Helm chart on AWS EKS, and it's manual deployment, and they are suffering infra ping. They need to move to different VPC, and they need to reduce their infra costs. And the most painful thing is there is no professional Pulsar support, so it's hard to do the maintenance on this Pulsar cluster, since it's not controlled by StreamNative. So we did migration. We're using the in-place migration for this customer. And so we migrate the zookeeper, bookkeeper, and broker and proxy. And once migrated to the StreamNative cloud, they are using StreamNative Cloud BLOC. So the data is still reserved in the customer's account. So it's very safe. And since they migrate to StreamNative Cloud, they will benefit from the powerful management with StreamNative Cloud Console and StreamNative Cloud automated operations. And during the migration, we also optimize the infra cost. We choose a cheaper node, and we schedule larger size of VPC, and we have better Pulsar cluster after migration. And the most important is the customer can achieve global technical support once migrate to StreamNative Cloud. And besides AWS, we also have GCP, Azure user cases. Basically, they are all the same use cases. They deploy Helm chart on the on AKS, GKE AKS, and then using in-place migration approach, migrate to StreamNative Cloud and benefits as much as possible. Okay. Feel free to ask me anything about Pulsar cluster migration, and we'll welcome you to migrate your existing Pulsar cluster to StreamNative Cloud. All right, that's all. Thanks for your time for listening to my talk, and have a good day. Thank you.
Okay, I think we are live now. And Max, it's late for you. Feel free to not turn on your video. But I think there's two questions in the Q&A. I can read these out, and Max, if you want to address that live. So first one is how does this geo-replication compare to Kafka Mirror Maker?
Hey,
Max, we're able to hear you. So the first question is, how does this geo-replication, I guess the question here refers to Pulsar geo-replication compared to Kafka Mirror Maker.
Geo-replication compared to Kafka. Yeah. Sergio, would you like to cover this question for me?
Sure. I know Max probably is not super familiar with this Kafka Mirror Maker setup. I can answer this one. I think Pulsar geo-replication is more a built-in replication, as what Max pointed out in his talk. The replication essentially is built in as part of the broker. So you can just kind of setting up the policy to say, I want to configure this namespace to replicate from cluster A to cluster B, and everything will be just done seamless there. And there's no additional components that you need to set up. Comparing to Kafka Mirror Maker, requires you to set up additional components. I would say you can think about as additional jobs that is running externally to the brokers, and then replicate data from Pulsar broker towards Kafka broker from one cluster to the other cluster. So that's kind of that setup is quite different there. Obviously there are many different aspects there. Last year's data streaming summit material, the PMC chair of Pulsar did talk about Pulsar geo-replication. I think that video would be worth check out. So that's the first question. And the second question, if I understand it correctly, for in-place migration, there should be a need to access the server resources for it to work. But what if Pulsar cluster is managed with no access to the resources? Then we would need geo-replication. What options would there be to still migrate all old data, even uploaded, if it's already uploaded? Max, do you want to address that?
Yeah. Thanks, and thanks, Sergio, for covering the first question. Yeah, for the second question, if I think this question is referred to what if Pulsar cluster is mentioned with no access to the resources? If I answer this correctly, if this means your existing path cluster is running is running on
I think it probably refers to like a more air gap environment where I think your target cluster doesn't have the access to the source clusters there.
Yeah.
So basically, there's no networking. There's no the network doesn't work between these target cluster and the source cluster.
Yeah. So if this situation, the network is isolated, as I mentioned in the presentation and the table. So in this scenario, we might need to set up a global zookeeper to utilize the geo-replication. And for migrates, all the older data even offloading it's already offloaded, we might need to manually create subscription and manually to replicate it. I think that's my answer. But if
I probably can add to what Max said there. I think it's probably the last sentence of this question is there's still I think migration still have other ways that we can do, like for example through tier storage. You can it's not like it's more I think what Max present is more like a live migration, so there's no downtime. There's also other approaches that you can push in all the data towards tier storage that is in object storage, and then if it's allow you to take certain downtime, you can back up your EBS volumes through some backup tools there, and then once you have this backup in both tier storage and EBS volume, then you can spinning up brand new clusters in the new locations there. This is also kind of a view of migration. So, but that migration will involve certain downtime that you need to take there because you need to take the snapshot and then load there. Obviously, I think migration is a very interesting topic. It's a very broad topic, and what Max cover in this talk is more like a live migration rather than like a downtime migration. But if there's a downtime permit, then there's more options that you can explore there.
Yes. Thanks, Jeff, for bringing this out. Yes. This presentation is more focused on the live migration and is without downtime.
Cool. The next two, there are two more questions. How geolocation works between Pulsar running Zookeeper as a metadata store to a cluster running Aksha, any potential issues with that? Max, do you want me to take that one for you?
Yeah. Thanks. Go ahead.
Okay. So geolocation essentially is just treated as a kind of two separate cluster. In place migration is more like you treat it as a kind of a one cluster. You kind of moving your deployments from one location to the other location. And geolocation, because they're independent clusters, they're it doesn't, so the source cluster or destination cluster doesn't need to access any of the Zookeeper clusters. It was just using Pulsar protocol for replication. So there's no issues saying your source cluster is running on Zookeeper, your destination cluster is running on Aksha. There's no problem with that. It's just because everything is talking through the Pulsar protocol. So hopefully that answered that first question. And the last question, Max, is what happens if target Pulsar cluster has less resources in comparison to source? What will be implication to the source cluster? Will it affect existing clients still sending, receiving messages to source cluster? I think Max, you probably want to clarify two cases there. If you're using in place migration with geo-replication there. The question doesn't say it's the geo-replication not in place, but for these two different approaches, I think the solution is different.
Yes,
Geolocation.
yes, exactly. And yes, this is a good question. So if the target has less resources, yeah, in less CPU, less memory, so which means if we use in-place migration and the bottleneck is bookkeeper auto recovery, in the bookkeeper needs replicating all the data from the old to the new, and this process can occupy lots of resources for bookkeeper. So this can bring some effects to the bookkeeper performance. And for the Geo-Replication, the Geo-Replication, since there is a built-in process in the broker, so the bottleneck will be the broker side. The broker will be running much slower than before, since the built-in replicator need to keep replicating and topics messages. And yes, so the answer is yes, it will have effect. So our suggestion is before migration, we should tune the cluster configurations, increase your CPU memory as much as possible to speed up the migration. Especially for in-place migration, we need too much more for our bookkeeper, much more CPU and memory, and to speed up our in-place migration. Yeah.
I think I just want to add one comment there on the Geo-Replication approach side. If the target cluster has less resources, it will causing a backlog that is pile up in the source cluster side. So it's not just because it's the destination cluster has less resources, but it would